Sorry, is there a chat too?
Okay, we're live.
Yes, there is a chat, Dave. It's on the left side. You click the button to the left that looks like a sort of dialogue box.
The green arrow? It says screen share.
No, the one above that.
There's no one above that. Did I say? Anyway, go ahead.
Okay. So thanks everyone for coming today. We are lucky to have with us Dave Wickers. Dave is one of the founders of the Open Web Application Security Project and also founded Aspect Security. He's a well-known security evangelist and security practitioner focusing on software security. And he's been around in the community for a while. He's one of the people who welcomed me into the fold and into the practice of application security like 11 years ago now. And Dave he was previously the sort of like project steward of the OWASP top 10. And he is going to present to us in this presentation about the 2017 OWASP top 10, which Dave did not steward, but has intimate knowledge of and is able to speak to. And I thought it'd be useful to have an outside expert come in and give us some of their ideas about the recent changes in the top 10. So I'm going to hand it over to Dave right now.
Thanks, Darian.
Hey, thanks. So I can share my screen somehow, I guess with this green button. And then I gotta find the presentation, which I don't see. Oh, here it is. No. I'm not a Hangouts expert here. This is that. There you go. You guys see my screen? See my presentation?
Yep.
All right. All right. So thanks for the introduction. I have a little bit of news too, which is kind of interesting. So as was mentioned, I was the top 10 project lead from basically its inception through the middle of last year. For various reasons, Jeff Williams and I, who was my co-lead, we decided that handing the project off to new leadership was in the best interests of the project and ourselves, actually. So we handed it off to Andrew Vanderstock and some other guys, and they did a great job at taking the release candidate that we wrote and stewarding that to a final release. And so that's what I'm going to be talking about today, is the final version of the OWASP Top 10, which is similar to, but not identical to, the release candidate that we originally produced. I was also on the OWASP board for about 10 years. I am, or now was, a co-founder of Aspect Security, but we were just acquired by Ernst & Young, so I now am an executive director at Ernst & Young. So anyway, that's a little bit about me. I've been doing AppSec for 30 years-ish, 27, anyway, a long time. So I have a little bit of background in this space. So the slides that I'm going to present, by the way, there's about 40 of them, and it's way too many to really present them in the detail they deserve. So I'm going to highlight what I think is important, particularly focusing on what's new. And I'm happy to provide a copy of the slides to you guys. So I'll send that to someone in the foundation and they can distribute it to the attendees or post it on your website or however you want to distribute it. And in fact, something similar to this might get posted at OWASP as a description of the top 10 from a presentation perspective. So what is the top 10 at OWASP? It's not a standard, although a lot of people treat it as such. It's intended to be an awareness document of the 10 most important risks you should probably focus on first. And there's certainly many more, including things that fell out of the top 10 over the years. It's been around since 2003. It's a de facto standard now because most of the application security community, or at least the web security community specifically, looks at it as like the flagship thing to focus on. And it's been released about every 3 or 4 years since its inception. So this is what is in the top 10 2017. There's a lot of familiar faces here. In fact, some of these things have been in there since the 2003 release, which is kind of disheartening, like cross-site scripting and injection and so on and so forth. But there are 3 new ones this year. 2 of them are XML External Entity Injection and insecure deserialization.
Hey, Dave.
Really good. Go ahead.
Your slides don't appear to be changing. Are you in presentation mode, or
I am.
can you?
Oh, so maybe the presentation isn't. What slide do you see now?
I still see like the slideshow view. Well, I just see PowerPoint. I see like the sidebar with all of the slides.
Oh.
Yeah.
I wonder if I have to tell Google somehow to share the. Can I just tell it to share my entire screen?
Take it off presenter view. There you go.
No, if I go to screen share, can I just say share entire screen?
You can do share entire screen.
There's full screen there. Let me try that. And then let me go here. And let me go here. Is that better?
Yes, much better.
And so now you see this transition where the red box came up.
Yes.
Yep.
All right. Thank you for chiming in and telling me I wasn't doing it right. Okay. So A4, A8, which I'll go into detail later, are kind of good, meaty, new technical security issues that we've been seeing a lot of lately. And so having them show up at the OWASP top 10, I think is a great addition because it gets some focus on these particular issues, which is the whole point of the OWASP top 10. Obviously, some things fell off, like cross-site request forgery and unsecure redirects and forwards, which are still, of course, important security issues that you should deal with and avoid in your web apps, but they didn't make the top 10 list this time. But I think that's okay, because giving some sunshine to some of the newer issues. And these are based on risk. The top 10 is not based on prevalence or how new it is, but it's based on the risk to the application and the data that it processes. And so XXE and deserialization vulnerabilities are big deals. I mean, even if they aren't incredibly common, when you do have these risks, they introduce a lot of risk to the application and its data. So it's a risk-based analysis that caused these 2 items to get added to the top 10. And a third item got added to the top 10 this year. So this is not common to have 3 new items in the OWASP top 10, but that's okay. And this last one's kind of an interesting risk. It's not really a vulnerability. It's about the fact that applications frequently have insufficient application layer security logging. And of course, then the correlation that you also probably don't have good monitoring. Now, obviously, if you don't have any logging, then there's nothing to monitor. So clearly logging is a prerequisite to good monitoring, but the lack of this logging and monitoring introduces risk because attackers can typically attack your application with impunity until they find an exploitable vulnerability, which is why A10 got added to the top 10 list in this release of the top 10. So I'll talk about all these in more detail in a moment. As I mentioned, it's about risks, not just vulnerabilities. And in fact, the number 10 that I just mentioned is technically not even a vulnerability. It's a lack of a security feature. It's not even a control per se in the traditional sense, but I actually think it is a fundamental security control that applications need and frequently don't have or just barely have and they're nowhere near sufficient to what they really need to be doing to reduce risk to your application. So the top 10 is, as I said, is based on risk. So we have a risk rating methodology that's based on a generic OWASP risk rating methodology that's been out at OWASP for years. And we basically came up with a very simple formula that says, hey, looking at the threat agent and how it works, we're going to look at the likelihood that you have this vulnerability in your application, the likelihood that an attacker could detect it, and then the likelihood that the attacker could successfully exploit it. So we give a ranking from 1 to 3 for each of those ratings, and we average those numbers. So that's what these first 3 columns here are. So we give you a score, we average them. So in this case, we're doing injection, which is A1, in other words, the most severe risk in the top 10. And the average ranking of these 3 is 2.6, and 2.6 out of 3 is a pretty high number. And then, of course, if the attacker successfully finds and exploits an injection vulnerability, the typical impact is very high, or we call severe in this case, which is also a 3. There is no higher number there. So that causes this to have a very high risk rating, which is why it's number 1 in our list. And all these numbers and these risk ratings are listed on every page of the OWASP Top 10 itself. And in fact, let me jump out real quick and go to a browser and see if I can bring up the top 10 document itself. So go here, go here. And so the top 10 itself is a PDF document that's about 30 odd pages. And there's some introductory material and there's some conclusion material, but the bulk of it is the 10 pages of the risks, and each risk is documented on 1 page. So for example, if I go to the next one, you can see that it's got a score of 322 on the likelihood factors and an impact of 3, which is why it's ranked number 2 instead of number 1. Now these, of course, risk rating factors are completely generic. They're independent of any particular organization or application or the data. So when you're doing risk ratings, you need to think about what these risk scores make sense for your applications or your organization. And that might cause the order of these risks to change for you. And that's totally fine, because you need to do your own risk analysis and your own risk decisions. We've just sort of done a generic one to give people a sense of the priority. But I wouldn't get too hung up on the order of the top 10. They're all pretty important, but of course, things near the top are usually more important than things towards the bottom. So anyway, we added 3 risks. We merged 2 into 1 to make some room, and we moved the priority of 3 of them. That's not a big deal. The methodology for producing it keeps evolving. We've been doing more and more data calls, getting more people involved in providing their both raw data and their opinion. The new top 10 team led by Andrew did a data call when Jeff and I had already done a data call, but that's okay. More data is good. Allowed them to do some deeper analysis. We're also making this data publicly available, so we can imagine people doing other interesting analysis on this data. In fact, I think this is the first time we've really made the data public through OWASP. Before, the contributors made their data public, but the format was inconsistent and wasn't all together, so it made it hard to analyze the data. Now it's all publicly available in a single source, in a single format that allows people to do some interesting analysis on that data. So this is a picture right out of the OWASP Top 10 that just sort of shows the changes between the previous version and the current version. And as you can see, a few items just transferred straight across, no change. 3 of them moved around, 2 got merged, and these 3 brand new ones showed up this one, and this one, and those are the ones I'll tend to focus on. So that's what's changed. So the rest of the presentation is really, and it's like 40 odd slides, and I can't spend a minute on each slide because we go way over on time, but in each one, I go through, what's the basic risk, an example, and then what are the best, the current techniques for avoiding that particular risk. And so some of these are going to go through quicker than others because they're probably old hat to you guys. One of the things that's changed a lot, and so I'll skip ahead for a second, I'll come back. But over the years, OWASP has been really, OWASP has been really focused on producing this series of cheat sheets. We wrote the first OWASP prevention cheat sheet or defense cheat sheet. There's an inconsistency there, but these are cheat sheets to help developers learn the most brutally effective and efficient techniques for avoiding vulnerabilities. And we started out with one on Crosssite scripting way back in I think it was 2007, might have been 2010, but I think it was 2007. And then in the last 10 years, that's grown into 50 cheat sheets on various topics. Not all of them are great and wonderful, but a lot of them are really good. And they allow you to really focus on that particular issue and the best way to deal with it. So, I can say stuff in this hour that we're going to be talking, but in terms of a takeaway, if you just learn, there's a series of cheat sheets on the top 10 topics, and in fact, many more, there's 30 or 40 of them, knowing that they're there, going out there, using those cheat sheets, telling your friends about them, and in fact, providing feedback to the authors of the cheat sheets would be fantastic, particularly if they don't address a kind of technology or issue you're dealing with. Let the author know, and frequently they'll do some research, or they'll get some friends, and they'll figure it out, give you an answer, and they'll add it to the cheat sheet so everybody benefits from that research and knowledge being in one place. So, and pretty much every item in the top 10, there's at least one cheat sheet related to that topic. And in fact, in some cases, there are a bunch of them, like this one, for example, lists 4 kinds of injection defenses for each in a different cheat sheet, which is a fantastic resource. So let me go back real quick. So what is injection? I mean, most of you, if you know anything about software security at all, are familiar with SQL injection as a big deal. And it is from a risk perspective. It's also very, very easy to avoid because there are very straightforward techniques for avoiding SQL injection. So the generic problem of any kind of injection is you're using an interpreter to process a command, like call the database or shell out to the operating system or what have you, and you're combining user data with the code of the query or command, and that user data is added unsafely to this command in such a way where that data can become code, and now you have user-supplied data executing as code in some interpreter somewhere. And that obviously can be really bad, pretty much game over, depending on the interpreter you're using, allowing the attacker to completely take over the server or the application or both. And in fact, frequently then being able to pivot off that server and go after everything else on that same subnet or wherever that application is hosted. So we typically think of this as SQL injection as the big problem, and it certainly is, but there's many other kinds of interpreters, as I've mentioned. So be very familiar with the interpreters you're using and make sure you're using them safely. So here's a very simple example of a SQL injection. You got a form. It's taking 2 parameters from a user, an account number, and a SKU. The developer blindly appends the user supplied data to the query. And in this case, it's the red text that's being appended. When that query gets past the database doesn't know that the black text is from the developer and the red text is from the user. It treats it all as one string that it assumes is safe. It executes the query. And if any data comes back, it sends all that back to the application. Then the application might in turn send the first row of data in this example back to the user, or it might send all the data back to the user depending on how the application is coded. So this is the classic SQL injection issue. Luckily, it's very easy to avoid this problem. First off, the primary recommendation in all cases is, can you avoid the interpreter entirely? Is there some way of doing the same functionality without calling an interpreter or a shell? That's the obvious best answer. Like, why are you shelling out to the operating system? Can't you do that natively in whatever programming language you're using, for example? If you can't avoid the interpreter, then look for an interface to that interpreter that's aware of data versus code and use it. Like in SQL, they have the concept of prepared statements that have bind variables where you're making it very clear what's data and what's code. And no matter what you pass in as data, it's going to be treated as data and never executed. There's other things you can do, of course, input validation, reducing privilege, so on and so forth. But the primary thing is making sure that data is always treated as data, however you can do that in that particular interpreter. So that's the classic risk. That's injection that's been #1 in the OWASP top 10 for the last 3 or 4 releases of the top 10. A2 is a combination, well, was broken authentication. It was also called broken authentication and session management before. It's the same exact thing as it was before. You know, how strong is your authentication? You store the user's credentials safely through strong hashing. Are those credentials protected in transit properly? What about all the ancillary functions related to authentication? You know, create account, change password, recover password, you know, secret questions for second factor authentication or machine binding or whatever. You got to think about all of those things. And in fact, of course, one of the best things to do to have good authentication is to, of course, build one authentication system and use it over and over and over across many, many different applications. So you're not trying to rebuild the same security control over and over. And of course, that's true of any kind of security control. Anytime you can standardize and minimize the duplication of effort for that control, the safer you're going to be and the less rework you're going to have to do to secure the same thing again and again. So here's an example of a session management issue. There's a zillion different authentication problems you can have. There's no way to do justice to the examples here. But in this case, they're putting a session ID in a URL. That's obviously a bad thing. You should not do that. Instead, it should always be in a cookie. Anyway, there's many, many examples of authentication issues. So how do you avoid authentication problems? Again, look at your architecture. Do you have simple controls? Are they standardized? You know, have they been well vetted? Maybe you use a third-party product that might be typically stronger than something you build yourself. Or maybe it's provided by the container or, you know, the system, the framework you're using, so you don't have to reinvent the wheel. And then anything you've had to build yourself, you know, you should assess. I mean, you should, of course, assess things you're using too, but clearly anything you've built yourself, you need to assess to make sure it's done correctly. And in fact, we have lots of guidance from OWASP on various factors related to authentication and session management. So I list 5 of them here. These are probably the most important ones on this particular topic, but there might be some other ones as well. One of the things I just want to mention real quickly, for example, is there's one on credential stuffing. You might not have heard of this before, but it's actually a pretty common attack for an attacker to steal someone's password database that they've implemented weekly so that the attacker can get the passwords out of it And then what they simply do is try all those same usernames and passwords on other web applications to see if the same user is using the same credentials in another site, which is a common behavior of users because users are lazy. And so you're going to get a series of login attempts on your site where there's one login attempt per account. So it's not going to look like a cracking attempt where they're banging, hundreds or thousands of passwords. They're just going to try one. So they're not going to trip your, 3 strikes and you're out login policy, for example. So the question is, can you even detect that attack? And if you do you do anything about it? Do you block that attacker? Well, if they're doing a distributed attack, then I don't know how you block them. So that's an interesting new problem that we're dealing with in the last 3 or 4 years related to authentication. So OWASP put together a cheat sheet to give you some basic ideas on how to get started, but this is still a very new area that deserves additional research. But at least you can be aware of this problem and think about, do I care about it? Am I going to try to defend against it? What does OWASP say? And certainly that's not a definitive article. So if there's things that are weak or missing or confusing about that article, let us know and we'll try to make it better for everyone. But anyway, that's just one example of some of the resources we've got available at OWASP. Sensitive data exposure is about protecting sensitive data in transit and at rest. This is a relatively obvious topic. For the most part these days, we're telling everyone to always use SSL for everything, or HTTPS, whatever you want to call it, transport layer security. That way your authentication tokens, your session cookies, your credit cards, whatever is all being exchanged and encrypted on the network. But what about data at rest? This is where a lot of organizations fall down. They don't encrypt data at rest because they don't think it's sensitive enough to deserve it, or it's too much of a pain. Or maybe they don't use encryption internally on the network because they don't see the risk. These are the kinds of things that we're talking about here. Ideally, you'd be encrypting all sensitive data wherever it is, and it would always be encrypted on the network inside or outside your environment. So this is what A3 is about. Here's an example of a credit card example where maybe the app owner knows that credit cards are sensitive, so they encrypt them at rest, but they didn't realize that some component was doing some logging and the credit cards were getting logged in the log files, maybe only when there was an error or maybe all the time. And so there's a side copy of these sensitive files and the attacker breaks in and steals those from an unexpected location. So in this particular case, it's not even an encryption problem. It's really they're logging sensitive data that they shouldn't log. And the answer is not to encrypt it, but rather it's to stop logging this sensitive data in the first place. And that way the data can't get stolen because it doesn't exist in this alternate location. So that's frequently the best defense for dealing with sensitive data is don't record it or throw it away quickly. There's been numerous situations where like a merchant, online merchant gets hacked, their transaction data gets stolen with just credit card information in it and other information that's sensitive. And it turns out, they got 7 years of data available in this system. Well, why? Why would you have 7 years of this data online available for an attacker to steal? How much do you need to be available online like that? Maybe 1 year would be fine, or 3 months would be fine. So if you simply trimmed that log, then you would significantly reduce the impact of a breach without requiring, fancy encryption or extra access control or so on and so forth. Now, of course, you still need to protect what's left in the log, but at least by reducing the volume, you've reduced your risk. So sometimes there's very simple things you can do to significantly reduce risk related to processing and storing sensitive data that doesn't involve anything really complicated at all, actually. So anyway, here's a bunch of tips on cryptographic storage. I did want to point out the password storage cheat sheet. A lot of systems build their own password hashing solutions. Sometimes those are very old legacy solutions that are 7, 10, 15 years old. They're using really, really old hashing algorithms. So upgrading your storage solution so that you're pretty confident that if an attacker did get a copy of it, you still have confidence that the attacker cannot reverse engineer the passwords out of it. That's where you want to be. And if you're not in that situation today, then you need to upgrade your storage approach. And you can do that in place without invalidating all your existing passwords. There are techniques for improving the security of password storage that are transparent to your current users, so you can improve that without causing a significant disruption to your customer base. So this is just an illustration of, people are typically using, SSL, let's say on the internet, but they're frequently not using it once they get inside their environment. And that's a risk that you got to decide whether that's acceptable or not. What's the technical complexity of adding internal encryption on the network? And what's the risk reduction that you get? Is this a risk you're accepting, or you're not even thinking about, or not? So we're seeing a lot of insider threat going on. Probably 40 to 50% of the breaches that we're seeing are still being done by insiders. So assuming that the inside is safe and the internet is the only source of danger is a very bad risk position to take in a lot of situations. So anyway, here's some guidance on this. Again, make sure you use good encryption. It could be commercial encryption. It could be using encryption built into your programming language like Java or what have you. There are some very complex encryption solutions you can use, but sometimes very, very simple solutions are just as good and have a lot less complexity. The main thing is to identify your sensitive data, decide what data needs to be encrypted, when, like on the network, at rest, and then making sure you consistently apply that encryption where it's needed. And again, as I said, avoiding storage of data is frequently the easiest way to avoid sensitive data exposure issues. So I'm already 35 minutes in, so I'm going to go quicker through some of these others, but I'm going to stop on the 3 new ones. Here's the first of the new ones. So XXE stands for XML External Entity. And so the vulnerability is like an XXE attack or XXE injection, sometimes people call it. XML, the standard, has this concept of an internal entity. So think of an external entity as either a URL, and that could be a file URL or an HTTP URL or whatever, or it could simply be a variable. Well, if you include this URL or this variable in your XML document, and the XML document came from an untrusted source like an external user, that URL can then reach out to whatever it's pointing to access data that it's not authorized for and potentially return that data to the user. It can also be used to cause an XML document to grow abnormally large and cause you to run out of memory or disk space or what have you. So let me show you what that looks like. I have an illustration here. So in this first example, we have this external entity called XXE fun, and that's now a variable, so I can reference that variable here. But the variable refers to a file. In this case, I put Etsy password. So here's the rub here. If XML external entities are enabled by your XML parser, which frequently is the case, then when this document gets processed, it's going to actually reach out, grab the copy of Etsy password, and replace that right here. Now, if you then return this XML document back to an attacker, then now the attacker has a copy of your password file. Now, typically these are caused by the fact that the developer had no idea that this was even a feature. They're not using it. They don't give a crap about it. But it's a feature that's available for an attacker to abuse. Here's another example where you declare an entity. Maybe it's an abnormally large number of the letter A. Let's say this is 10,000 of them. And then you have another element that's got 10,000 references to A. Then obviously this is going to expand in size to 10,000 times 10,000, whatever that is, a large number. So that's not a huge number, but you can see you could quickly repeat this process and with a few lines of code create documents that are gigabytes or terabytes in size. And of course, that would exhaust all resources on the machine. So those are examples. These are trivial examples of attacks. The question is, how do you avoid these? Well, typically, basically the way to avoid these is either use an XML parser that has external entities disabled by default, which is common in some languages but less common in others, or disable it yourself. So here's a Java example of a parser called Xerxes, which is, in this case, a document builder factory is the name of it. So there's simply a feature you can set called disallow document type declarations that will disable the XXE feature. And so if it then parses an XML document that has an XXE entity in it, it'll throw an exception saying, hey, sorry, that's not allowed, and you're safe. Now, in some cases, you want to allow these external entities or these entity definitions, but you want to say, fine, but they can't be external. They can't point to the file system. They can't point to URLs. So you can partially disable it without disabling it completely. But it's very rare that I see situations where people are even using this feature at all. So it's better off to disable it entirely. In fact, I would probably execute all three of these set feature commands typically when using this parser just to make sure. Now, this is just one parser of dozens that exist out there. So what we've been trying to do in the XML or XXE defense cheat sheet is list for every parser that we're aware of across many different languages. Is it safe by default? And if not, how do you make it safe? And I've been actually working on that cheat sheet for years. And so everything I know about XXE is documented in this XXE prevention cheat sheet, which is obviously a fantastic resource for you guys learning about what XXE is and how to avoid it. So here's some basic guidance. First off, why would you even accept an unvalidated XML document from an end user? I mean, that is a common behavior, so it doesn't surprise me people do it. But if you can avoid it, then you solve the problem. But if you can't avoid it, make sure you're either using a parser with it off by default or disable it yourself. In some cases, there are parsers that you can't turn it off. And in that case, you need to replace your parser with a different parser that can be made safe or is safe by default. So this is actually a very, very easy problem to solve. You just got to look for it, set a few switches, and move on for the most part. So even though this is a big deal in terms of risk, it's mainly because of lack of awareness. And I suspect now that it's so high in the top 10, the awareness will bloom in the next 3 years. That's the goal of the top 10. And then people will become aware of it. And this XXE issue would hopefully drop significantly from the top 10 in the next release. Ideally, it would drop off the list entirely. I don't suspect that'll happen in one cycle, but maybe by the 2023 version of the OWASP top 10, I would hope XXE would fall off because everyone knows about this problem and the easy ways of avoiding it. Access control, this has been around forever. The main thing is you gotta make sure that the user is authorized for the functionality they're interacting with and are authorized for all the data that they're interacting with and in the way they're interacting with that data. Are they authorized to read it, modify it, create it, destroy it? Can they grant other people access to that data, etc.? So it's very, very easy to make mistakes in the access control area because it's all custom. and tools can't help you at all in figuring out if you've done this right or wrong or what have you. This has required a lot of custom development work and a lot of custom verification work for dealing with access control. So I've got some slides here on some examples like force browsing a directory to get access to functions that you maybe can't see, but can still browse to, and you should still be denied access. Of course, it's trivial to modify the identifier of a object reference and try to access someone else's account. These are relatively obvious attacks. You just got to be really hyper aware of all your endpoints for functionality and data access and make sure you've built that safely. So we've got some examples here on how to do that right on this slide here. Security misconfiguration has been around forever. A lot of people argue this doesn't belong in the OWASP top 10 because they don't think of it as a developer issue. Maybe that's true, although with DevOps now, configuration and it's all developer issue, right? So to me, this is even more relevant today than it was when we first introduced this way back in 2004 or whenever it first came out. I mean, securely configuring your components, your web server, your app server, your database, your firewall, your web application firewalls, your frameworks, Struts and Spring and Hibernate. All of these components have security configurations, and people screw them up. They don't have the configuration in configuration under configuration management. They can't automatically deploy the same environment over and over, be consistent. They don't have a good way of auditing the configuration to make sure it's correct and it hasn't changed in an unexpected way. So a lot of work needs to be done around this. And because of that, this is still a significant risk in a lot of organizations. And so anyway, we've got some examples of here, and I'm not going to go into them, but this is still a big risk. And I think with DevOps, it's becoming even more critical. People need to spend even more time on this particular security risk. Cross-site scripting has been around forever. It's a complex topic. It has been dropping in the top 10, which is good in terms of risk because everyone's hyper aware of it and has been focusing on it, but it is a complicated issue. I really can't do justice to this topic here because I could spend a whole hour or 4 hours on this particular problem. So I'm not going to spend a lot of time on cross-site scripting. I am going to mention that, sort of traditional cross-site scripting where you include data in a page and that script executes immediately is kind of fading away because now we're doing everything with Ajax and things like that. So the page is typically static, and then we send data to the page using Ajax calls. And we can still introduce cross-site scripting when we do that because we're using a JavaScript method or a JavaScript library method that if it's given snippets of JavaScript, it'll actually build active JavaScript when it updates the DOM for that page. And you can end up with cross-site scripting that way. And that's a type of cross-site scripting called DOM-based cross-site scripting, which is a very complex topic to talk about. And I can't really do justice to that. There is several cheat sheets on the OWASP top, there are several cheat sheets related to cross-site scripting. I just want to mention those here. The original one is the XSS cheat sheet, which was the first prevention cheat sheet we wrote. And that talks about embedding user data on the page as you build the HTML and the JavaScript and the links or what have you. And that still is definitely a risk. People still do this. But that's not the common way of building web apps today. As I said, most of them do DOM-based access, or DOM-based, or Ajax-based websites, where they're using JavaScript frameworks to dynamically change pages on the fly. And so we've got another cheat sheet on XSS related to DOM-based XSS, which tries to give you some guidance on this topic. So I definitely read it, but it is a complicated issue. The solutions are very dependent on the JavaScript frameworks you are using. So there's no way in this one cheat sheet we can give everyone the guidance they need for any kind of framework. You really need to understand which JavaScript methods can create active content and which ones cannot. And then for the ones that can, you need to make sure you trust the data that you're passing into those calls, or you've validated that data to make sure it's safe before you do so. And so it can be very tricky to find DOM-based cross-site scripting flaws and then fix them, which is, of course, somewhat of a good thing because it makes it hard for attackers to find them and fix them too. However, there's some really clever guys out there that are really good at this stuff, probably far better than the average developer. And so the advantage is definitely in the attacker's court in finding and exploiting DOM-based XSS versus the developers avoiding all of them in their web app that they're building. So the second new OWASP Top 10 topic is insecure deserialization. So it is not uncommon for applications to take a plain old, like a Java Pojo or whatever language you have, which plain old Java object. So it's a plain old whatever language you're using object, and serialize that into JSON or XML, or it could even be binary, and then send that object to somebody else, a browser or wherever, put it in a database, something, and then try to accept it back from the user, and then turn it back into the object it originally was. The problem is the attacker, of course, can tamper with that serialized object, and frequently, if they're clever about it, they can actually get arbitrary code execution as a side effect of the deserialization process, and then it's completely game over. So this is a really big deal that has really ballooned in the last 4 years as people start focusing on this particular risk. I have a few examples. These are all open source or public examples with CVEs associated with them. All of these happen to be last year, but there's many, many more. These are just a few. And these are all in usually typically in open source components. Some of them might be commercial products. So we've got some JavaScript libraries, we've got some .NET components, we've got some Java components. You can see this is not specific to any particular language. In this case, the solution to these 4 specific examples is to upgrade your component or your product to a version of that product that has a fix, right? So that makes avoiding use of known vulnerable libraries maybe even more important, which is A9, the next topic. But if you have a deserialization issue in your code, whoops, I went the wrong way, sorry. If you have deserialization issues in your code, then there's a number of ways to fix it. So my first suggestion to avoid deserialization components or issues is to just don't do it. Don't send serialized objects to your users, and then you won't have this problem. But if you must, then you need to make sure that those components are safe. So how do you make a deserialized object safe before actually trying to deserialize it? Well, one way is to provide some kind of integrity seal. So in other words, if you send it to them and you expect it to come back unmodified, sign it in some way and verify the signature. And if it fails, then you don't deserialize it. You can also, of course, harden your deserialization mechanism to only support a limited set of object types, and that'll reduce your risk. And there's some techniques in the deserialization cheat sheet down below where they give you specific guidance on how to do that in certain situations, like in Java, for example, and things like that. So there are some basic techniques for avoiding deserialization, but a lot of these are very specific to the technology that you're serializing and deserializing. But of course, step one is awareness. Are you even aware that you're serializing objects, sending them to users, and then having the users send them back to you? A lot of times they don't realize they're doing it. Maybe it's automatically happening because some framework hydrates and dehydrates these objects for you, and you're not realizing it's happening. So again, the top 10 is about awareness. So step one is, are you even using serialization technologies at all? And if you are, do you intend it? Did you intend to? And if you did, what steps are you taking to avoid that particular problem? So this deserialization sheet is very new, but I certainly encourage you to review it and make your friends aware of it. A9 is about use of known vulnerable components. That's been introduced in the last top 10 as well. We got some pushback that people thought that was silly. And then very quickly people realized, nah, that's pretty major deal. And in fact, some of the biggest breaches that have happened in the last 4 years have been exactly because people are continuing to use known vulnerable components because they have no mechanism for detecting and fixing these issues quickly. And in fact, the attackers know this, so the life cycle of CVE is reported in library X to live exploits are happening against that CVE have dropped from 1 to 2 months, maybe 2012, 2013, to 48 hours, maybe even 24 hours. So think about that. You're using a framework in your web app. The CVE comes out right now, 3:30 Eastern time. And in 24 hours, the attackers are going to start exploiting that and taking over servers because it's got a remote code execution issue. How are you going to fix your portfolio of applications that have this problem? Now, not every app will have this problem, but let's say you got 12 apps out of your 100 that have this specific problem. Can you identify those apps, develop a fix, like upgrade the library to the patched version, regression test it, and deploy it in 24 hours? The answer for most organizations is no. Not even no, it's hell no. And yet that's where we need to be. And so this is a big deal. There are some commercial technologies out there that can help you detect these issues. There's some free technology like OWASP dependency check that can help you detect these issues. But you also might need some kind of patching technology that allows you to mitigate the issue until you deploy a real fix, because the time cycles are getting so quick that actually rebuilding and redeploying an app is just impossible in the time frames that we need to deal with this kind of issue today. So you guys heard about the Equifax, for example. They got hit by a struts exploit within a few weeks, or maybe just a few days of the release of that CVE back in like May of 2017. And 140 odd records, 140 million records got stolen because of that breach. So I only got a few minutes left, and then I'll take questions for whoever wants to hang out. The very last one of the OWASP top 10 is lack of logging and monitoring. And as I mentioned before, web apps are frequently very polite. They'll let people attack them all day long. They'll simply provide error messages like, sorry, that didn't work, please try again. And of course, the attackers are happy to oblige, and they'll attack and they'll attack and they'll attack until they finally find the vulnerability that they are looking for and figure out how to exploit it. And then they'll do some damage, right? So why are our web apps so polite? That's nonsense. You wouldn't let someone walk up to your front door and start chopping away at it with an axe for 2 hours without calling the police and telling them to take a hike. But we don't do that with the typical web application. So we need to log security events. We need to have standardization. We need to know we have sufficient security events. We need to make it easy for developers to comply with this policy, like hopefully build this logging into standard security controls, then make it easy to add custom events when they have to build custom controls. We need to be able to distinguish these security events from non-security events. Then we need to monitor those events so that we have, real-time or near real-time event detection, so we can raise alerts, maybe even lock out attackers, detect, define thresholds of events, not just single events, so that when a threshold is exceeded over a period of time, that triggers some kind of action. But there's very few systems that we see that have anything close to what I would call sufficient security logging and monitoring in the typical web app. And OWASP agrees by putting it in the top 10. One of my favorite OWASP projects has been around for a decade. It's called OWASP App Sensor. And it talks about this kind of stuff. It gives, there's a reference implementation for a Java library. There's guides that are written, really well-written guidelines to give you advice on how to implement this kind of stuff. So OWASP has been thinking about this problem for a long time. It just hasn't risen to the level of the top 10 until 2017. But just like you don't have network, like today, if you didn't have network layer intrusion detection, people will look at you like you're crazy, right? We've had that, there's been an expectation for network level IDS for the last 5, if not 10 years. But there's no such expectation at the app layer yet. We're hoping the top 10 is going to tip that scale, and hopefully within 3 to 5 years, people will look at you funny if you don't have really good application layer intrusion detection. And that's really the goal of the top 10 putting this in, even though it's number 10 on the list, is, hey, this is really important. This is a big risk if you don't have good security logging and monitoring. So anyway, I got some summary slides here that I don't have time to cover, and that's all I've got. Like I said, I'll make the slides available, and I think they wanted to record the session and make that available. That's totally fine. Is there any questions, or I don't know how you want to go through the next part of this, Darian, but I know we're sort of out of time, but I'm happy to hang out for as long as people have questions. So whatever you want to do.
Any questions from anyone in the Hangout or in the room there?
Yeah, I haven't seen any come in through IRC or YouTube yet, but if anyone has any, this would be a good time.
And people could send me an email later, so I'm not very hard to find, but dave.wickers@owasp.org works. I'm happy to answer your question today, next week, next year. I do get questions out of the blue once in a while, and I'm totally happy to help you. My typical answer is I point you at an OWASP resource that frequently I helped write and say, hey, why don't you start here? And if you got more questions, ask. Anyway, I'll take questions at any time. So.
Well, I think we can go ahead and wrap up if there's no questions. We don't want to keep you too long, Dave. Again, thanks for doing this presentation. It was great. Really appreciate you sharing your time with us. Yeah, it was excellent. Thanks a lot.
All right. It's basic stuff for me, but it's getting this awareness out is great. So I'm really appreciate you actually inviting me to do this, because that's what the top 10 is all about. We want to spread the word. So let everyone else know about this. They can either hopefully watch the recording or at least get the slides, reference the cheat sheets. And a lot of these, again, aren't that hard to deal with. It's awareness. Lack of awareness is our enemy still in 2017, which is really unfortunate. Anyway, that's all I got. Thanks.
All right. Thanks again.
Thanks, Dave.